Welcome to Lesson 7, Applications to Exponential Functions, Day 2. So yesterday we looked at half-life and doubling period. Today we're going to look at appreciation, depreciation, and we're going to look at population growth. All right, here we go. We're going to start with population growth, and we're going to define the equation here. Here's my equation. So P of t is equal to P naught times n to the exponent t. P of t is the population after time t. T is time. P naught is the initial population. Again, we call this P naught. In England, they don't actually say the number 0, they say the number naught. So that's kind of where we get that from. So the population after time 0, which is currently the initial one, and n is the growth rate. So example, 2% growth rate, what we do here, that would be 1 plus. Why is it plus? Because we are growing. So that's 1 plus. Again, why? Because it's growth. So we're adding 0.02. That is the 2% as a decimal. Mr. Wills, where did this 1 come from? Again, 1 times anything is itself. So we're starting off with 1. And then from there, we're going to grow. All right, let's look at the first example. Here we go, the town of Newmarket. The town of Newmarket, population 1990 was 45,500 and 85,000 in 2010. Find the expression for the population at time t after 1990. Since we're going to start here, that's going to be time is 0. That means that this guy here, this is going to be our P naught. So we've got our P naught. Now we also have this. We have 2010, so this is actually another t value. This t will be 2010, but minus the initial, so minus 1990. So if I do this quickly in my head, I get t is equal to 20. How is that helpful, Mr. Wills? Because now we know that p of 20, the year 2010, that's equal to 85,000. And again, not again, but if you want to look this up, it's actually the truth. The population in Newmarket was 45,500, and in 2010 it was 85,000. I like accuracy in my questions, so there we go. So I've got P of 20 is equal to 85,000. I've got my initial P naught, so the only thing I'm missing right now is my n, so I need to solve for n. So again, the equation is P of t is equal to P naught times n to the exponent t. So I'm going to sub in what I know. I know P of t, it's 85,000, is equal to P naught, 45,500, times n, all to the exponent of 20. First thing I'm going to do here, divide out the 45,500. When I do this, I get 1.868 is equal to n to the exponent 20. How do I solve this? Well, I am going to get rid of this exponent of 20, I'm going to take the 20th root. So take the 20th root of this side. And again, using the formula here, this is really n to the exponent of 20 over 20, which is equal to just n. Perfect. But what I do to one side, I have to the other side, so I'm going to take the 20th root here as well. So what do I have? I am going to have here, rounding to two decimal places, 1.03 is equal to n. There we go. Beautiful. So I've got my n here, which is really my equation, because now my equation will be P of t is equal to 45,500 times 1.03, all to the exponent of t. Done. Beautiful, Mr. Wills, thank you. The population, now it wants the approximate population in the year 2020. Well, here my t will be 2020, whoops, try that again, 2020 minus the initial where I started 1990. So here my t is equal to 30, so then I want p of 30, so this is going to be 45,500 times 1.03, all to the exponent of 30. So here I am going to have, if I do this quickly, 110,440. We need to round to the nearest whole number. Why? Because you can't have a decimal number of people. Therefore, in 2020, the estimated or projected population of Newmarket, my hometown, woohoo, oops, will be 110,440. Oops. All right, there we go. So there we go, population growth. All right, let's continue on to depreciation, appreciation, word problems number 2, type number 2. So this is when items lose or gain value over time. So lots of examples of where things can gain or lose value over time. In fact, there is very little, if anything, that actually stays stagnant over time. Most things either gain value or lose value over time. So here's my example 2. A car depreciates by 15% per year. If you buy a car for $15,000, find the value of the car after 3 years. So here's my equation that I'm going to use here. My equation looks like this. V of t is equal to a times n to the exponent t. So let's define what some of these are. V of t is the value after time t. T is, of course, time, and whatever units here, so time here would be years. A is the initial value, so my initial value here, let's write this in, whoops, my initial value would actually be 15,000, that's my A. And then finally, N is the depreciation appreciation rate. So here, depreciation, you can see clearly it's 1 minus. Why is it minus, Mr. Wills? Because we're losing value. So minus percent divided by 100. For appreciation, it's going to be 1 plus percent divided by 100. Remember, BEDMAS says you have to do percent divided by 100 first before you add or subtract. All right, so here we go. I want to do this. So I've got my A. I've actually got T, so T here is 3. Now depreciate, so I'm going to start with 1. Since it's depreciation, 1 minus 15 divided by 100. If I do this in my calculator, I get 0.85. What is that, Mr. Wills? That is my N. So I've got my N, I've got my A, and I've got my T. Really, what else is there? Just need to solve my V of T. So I'm going to do it over here. So I've got V of 3 is equal to 15,000 times 0.85 to the exponent 3. So here, if I do this quickly, I am going to have 9,211.88. Why can you have decimals here? Because we're dealing with money, so it should go to decimal places. So therefore, I'm going to write a therefore statement. Therefore, after 3 years, the value of the car will be $9,211.88. Done. All right. Let's continue on here. I need to erase that. Excuse me. Sorry. All right. Next question says this. What is the value of car after 3 years? So here again, we've got T. If the car appreciates, appreciates, so that means we're going to do 1 plus. The word appreciates means it's gaining value, 0.5, so it's going to be 5 divided by 100. I do that in my calculator. I get N is equal to 1.05. So I've got my N. Beautiful. Let's highlight that. So there's my N. Oops. I've got my T, which is 3. And I still am going to use my A from before. So let's pretend my A was again 15,000 from example 2. And I'm going to solve. So I'm going to have here the value, what the heck? The value after 3 is equal to 15,000 times 0.85 to the exponent of 3. Put that in my calculator. Kaboom, I get 17,364 decimal 38. Therefore, after 3 years, the value of the car will be $17,364.38. Mr. Wills, yes. What kind of car is that and where can you buy it? Why do I say this? Because cars are one of the worst investments you can make. They normally depreciate in value quite quickly. They are arguably a necessity of life for some people not. If you live in a very urban space, but for people that live in more rural spaces, the cars are a necessity and usually lose value quite quickly rather than gain value. So that's why I wrote that comment there, kind of as a funny joke. Not funny? Fair enough. All right, let's continue. Last example. Here we go. From question 3, determine how long will it take for the value of the car to appreciate to 18,683. So right here, this is my V of t. My A is still 15,000. My N will still be 1.05. So how long? How long? So here I'm going to solve for t. All right, let's do it. So I'm going to have this. I'm going to have 18,682 is equal to 15,000 times 1.05 to the exponent t. All right, first thing I'm going to do is divide both sides by 15,000. 15,000 on this side, 15,000 on this side. What do I get if I do that? I'm going to get 1.245 is equal to 1.05 to the exponent t. Oh dear, what's happening here? I need to solve for a variable in the exponent. What am I going to do, Mr. Wills? I am going to, like I did in my last lesson 6, I'm going to take log of both sides. Again, you can guess and check. I'm not wasting my time guessing and checking. So I'm going to take log of both sides. What does that do? Well, if I take log of this side, okay, that's just going to give me some sort of value. I don't really know what it is right now. But the beauty of this is I can do log of 1.05 to the exponent t. And the beauty of log is you can bring that exponent down and make it a coefficient, which makes it much easier to solve. So I'm going to have here log of 1.245 is equal to t log of 1.05. Divide both sides. I want that t by itself by log of 1.05. Divide this by log of 1.05. And so what do I get if I do this? I get t is equal to log of 1.245 over log of 1.05. And so t is equal to approximately 4.5. All right. So therefore, the car will appreciate to 18,682 after, 4.5 years. Done.